I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. In September 2025, GTG-1002 hit approximately 30 organizations across technology, financial, government, and chemical sectors. Claude Code, Chinese state-sponsored operators, human operators made 4 to 6 decisions per engagement. Reconnaissance, exploitation, lateral movement, credential harvesting, and exfiltration, all handled autonomously by the AI, processing thousands of requests per second. I'm Andreas Hamberger. This is the Hamberger Report, where I cover enterprise architecture in the age of AI agents. Chapter 5 of this series gave you the lethal trifecta as a framework for predicting AI weaponization. This episode gives you the evidence that the framework describes what actually happened, not how fast did GTG-1002 move, but what architectural conditions made it possible. The answer is the same across 7 documented incidents. Apply the trifecta to GTG-1002. Leg 1, Claude Code held read access to code bases, configuration files, and in many developer environments, credential stores. Leg 2, attackers social engineered the model with role-play prompts, untrusted content injected into its context and processed as legitimate instructions. The model had no mechanism to distinguish authorized commands from adversarial content embedded in what it was reading. Leg 3, Claude Code's agentic mode could write files, execute system commands, and transmit data through legitimate developer channels without triggering any alert. All 3 legs active. The attack followed as a logical consequence of the architecture. The failure was not in Anthropic's model design. It was in deployment ambient permissions inherited from the developer's account, no semantic monitoring of what the agent was acting on, and no human confirmation step before high-risk execution. One month before GTG-1002, a supply chain attack called NPM-S1 Angularity demonstrated a different path to the same outcome. Malicious code injected into popular NPM packages, targeted AI coding agents, running with permissive flags, dangerously skip permissions in Claude Code, YOLO in Gemini CLI, trust all tools in Amazon Q. Those flags exist for developer convenience. They disable the confirmation steps that would otherwise require the agent to seek approval before accessing sensitive files. A developer enables them under time pressure and forgets to disable them. The attacker inherits everything. The malware harvested SSH keys, GitHub tokens, cryptocurrency wallets, and environment variables, then uploaded them through the victim's own GitHub account using repositories the victim had not created. No external command and control infrastructure. The data moved through channels that security monitoring treated as normal traffic. The malware ran for 5 hours and 20 minutes before detection. In August 2024, security researchers disclosed a conceptually identical failure in Slack AI. An attacker posted crafted instructions into a public Slack channel. When a legitimate user later asked Slack AI a question, the AI retrieved the injected instruction alongside legitimate context and exfiltrated data from private channels through its own response output. The victim never clicked a link, never opened an attachment, never granted additional permissions. The attack executed through entirely normal AI assistant interaction. Same architectural failure in both cases. The agent could not distinguish its user's instructions from adversarial content embedded in what it was processing. Every enterprise AI assistant with read access to sensitive data and exposure to content from untrusted sources carries the same gap. Seven incidents, 5 platforms, 5 structural failures that appear every time. Pattern 1, inherited permissions, never verified. The AI holds delegated access granted once at setup. Actions are never re-verified against a specific task at execution time. Pattern 2, content processed as instruction. The model has no mechanism to apply differential trust to content from different sources. A role-play prompt, a package dependency, a Slack message, a ServiceNow ticket, an email body, all treated as authorized commands. Pattern 3, no human checkpoint at the critical action. GTG-1002 had 4 to 6 human decisions across an entire multi-stage espionage engagement. Autonomous execution is valuable precisely because it removes the human bottleneck. The same characteristic is what made every attack in this chapter possible. Pattern 4, exfiltration through legitimate channels. Not one of these attacks created new communication infrastructure. Data moved through developer pipelines, GitHub, email, AI responses. Signature-based detection was structurally useless against all of them. Pattern 5, the lethal trifecta, fully active. In every high-impact case, all 3 conditions were present simultaneously. Where only 2 were active, attacks either failed to execute or had substantially limited impact. Restrict any one leg, and you typically disrupt the chain. Now bring this to New Zealand. Cordia's 2026 NZ Business Cybersecurity Report found that AI-related cyber attacks doubled in a single year, 6% of all incidents in 2024, rising to 14% in 2025. Microsoft 365 Copilot, ServiceNow, Slack, and developer toolchains are running in NZ organizations right now. The vulnerability patterns are identical regardless of geography. The average NZ SME breach in 2025 cost $173,000. The Privacy Act maximum penalty sits at $10,000. You are self-insuring against a $173,000 average loss with a $10,000 regulatory ceiling. The business case is prevention, not penalty management. On the 1st of March 2026, the lethal trifecta was demonstrated in a form that no security framework document had anticipated. Iranian drones struck 3 Amazon Web Services data centers, 2 in the UAE, 1 in Bahrain. 2 of 3 availability zones in AWS's Middle East region went offline. Banking services, payment platforms, and government systems across the Gulf collapsed. The Uptime Institute confirmed this as the first military attack on a hyperscale cloud provider in history. Apply the trifecta to the physical infrastructure. Leg 1, the same physical servers housed commercial banking data and military compute, collocated on common hardware. Leg 2, a cloud data center in an active kinetic conflict zone is exposed to ordnance, the most direct form of adversarial action possible. Leg 3, civilian financial services and military workloads ran through shared infrastructure with no physical isolation. All 3 legs fully active. The attack followed as a logical consequence of the architecture. The architecture lesson is structurally identical to every software incident in this episode. The cloud is not abstract, it is concrete, steel and copper at a specific address in a specific jurisdiction. Architecture decisions about where AI workloads run are physical decisions with physical consequences. 5 actions for your review this week. Audit every AI agent's permission scope against the specific task it performs. Implement semantic filtering that treats document content, email bodies, and ticket text as untrusted input. Require human confirmation before any agent executes a high-risk action. Enable behavior-based anomaly detection. Legitimate channel exfiltration is invisible to signatures. And run the lethal trifecta test on every AI deployment in your environment. If you are an architect or CIO figuring out what agentic AI means for your practice, subscribe. And if you want structured TOGAF training adapted for the agentic age, the link to my practitioner course is in the description. Subscribe to the Hamberger Report, new videos every day. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.